So good morning, everybody. My name is Mark O'Reilly, and I am with the Connexus Group. The Manufacturing Growth Alliance is a subsidiary of the Connexus Group. MGA is a membership-based organization that provides services to help manufacturers build smart, lead strong, and establish a pathway for future growth. The services drive solutions that will make manufacturing in Michigan the most competitive and prosperous in the nation. Manufacturers are leveraging new technologies to support customer demands. The virtual knowledge sharing webinar is designed to help small manufacturers become aware of the additive manufacturing and how technology is a solution to many challenges that manufacturing have or will see in the near future. MGA have partnered with Centropolis Accelerator at Lawrence Technological University to offer this webinar focused on Industry 4.0 technologies to solve current problems manufacturers are having. Before I introduce our facilitator, I have a few housekeeping items to share. First of all, we encourage questions and comments. Please type your questions in the chat box at the bottom of your screen. We will monitor questions as they come in and will share the questions with our presenters. We are also recording the conversation today to provide the content to manufacturers after the webinar. Now, let's introduce our facilitator. I'd first like to introduce John Betts from Automation Alley and Dan Radominski from Centropolis Accelerator. Dan is the Executive Director of the Centropolis Accelerator, and he has extensive experience with Industry 4.0 technologies and manufacturing. Thank you both for facilitating the conversation today. And with that, I'm going to pass over to John.
Nope, to Dan.
Oh, to Dan. Hey, to Dan. Thanks.
Yeah, well, thanks for having us, and grateful to have the Michigan, our Manufacturing Growth Alliance supporting this Industry 4.0 Michigan across the state, which has been supported by the Michigan Economic Development Corporation to support kind of regional activities to educate small to medium-sized manufacturers on I4O technology and more importantly, how to implement that into their operations. Today's discussion is really focused more on 3D printing and additive manufacturing and some of the innovations that we've been seeing through the I4O Accelerator, and specifically helping manufacturers understand how to design better for manufacturability through additive and utilize these technologies in a meaningful way. So I am going to pull up my screen and actually share with you the document, and I'm going to ask my partner, John Betts, who is with Automation Alley, to kick us off and talk a little bit about Automation Alley, their I4O initiatives, which includes I4O Accelerator as well as other things. So, John?
Sure. Good morning, everyone. Thanks for joining us today. As Dan said, we're partners on this effort. And what we did in 2020 was we started well, let me do Automation Alley first. Automation Alley is a membership organization. We're headquartered in Southeast Michigan, but we're statewide. And we want to reach out to every manufacturing company in the state and bring them in as an essential member or as an enhanced member at a higher level, of course, but everyone's eligible for an essential membership. And we're the knowledge center for Industry 4.0 for the state of Michigan. We bring together new ideas on how these digital technologies are changing physical manufacturing. We have our membership groups from academia and industry that are there ready to help companies that want to learn more about what's going on with these new technologies and how to integrate them into their offerings. And as part of that, Dan and I work together on our accelerator program that we've started up that's able to make investments into emerging technology companies that are developing digital technologies in this space, and working with the manufacturers across the state to get knowledge about those programs to them. So I'm going to do just a little bit on Automation Alley. Like I said, we're a membership organization. We have memberships for all the manufacturers in the state. Our next big event that's coming up that we do is going to be the Global Outlook in January. But what we're doing right now is through our grant with the MEDC, in addition to that essential membership that I mentioned earlier, Every manufacturer in Michigan is going to get a ticket to that conference, Integrate, which is coming up in May of 2020. And we were also working with all the regional grantees across the state to extend that knowledge about what's going on. And then should a company decide that they want to pursue something a little bit more into this, we work with the MMTC to help do an engineering study and an assessment on the companies. We work with our partners at the regional grants to the demo fund to help companies get matching funds from the state for integration demos. And overall, we work to support the local or the regional grantees like MGA and extending that knowledge to all the manufacturers. So if you want to hit the next slide, Dan, let's see what's up next. Okay, I already mentioned that essential membership program. The link's at the bottom of this slide. And if you have any questions on that, you can reach out to me. I'll put you in touch with the right people here. If you've got questions in general about Industry 4.0, we're developing a use case database that should hopefully come up with a custom response to what your questions might be. But you can always reach out to us and we'll help you walk through that. Next slide. Getting a little late, I'm frozen. Well, I don't know if Dan's frozen or if I'm frozen. And now he's moving just a little bit. So why don't we go to the next slide, Dan? All right. Project Diamond. I don't know if Pierre was speaking separately on this today. So if you want, Pierre, if you're not muted, if you just want to give a quick overview on what Project Diamond is.
I will, John, I think you can do the introduction, but if you want, I'll do it. The part I present today is more technical, but it refers to Project Diamond a lot in what I present.
So I'll do this slide and then Pierre will tell you a little bit more about it later on. Project Diamond is an initiative that Automation Alley is helping lead with a couple of the counties here in Southeast Michigan. And you can see the definition in the body of that slide there. But what it is we're networking together 300 different companies that have got a 3D printer that had been granted through this program. And what we're doing is helping those manufacturers understand the power of this new tool that they're going to introduce to their company. And what we're going to do is help network them together so that they can collectively and independently respond to opportunities in the marketplace, that they can help Michigan companies can help other Michigan companies in understanding what they're doing, sharing success stories, and et cetera. So we'll expand this project moving forward, and Pierre will go a little bit more deeply into it later on. So you can go to that next slide here. Automation Alley is also in partnership with the World Economic Forum. We're the North American AM Hub, which is an advanced manufacturing hub. And what we're doing is bringing together leaders and policymakers on what's important to manufacturing. Regionally here, but for all of North America. And this helps us inform policymakers on what they can do to make things better for Michigan manufacturing and for US manufacturing as companies look to locally source and locally manufacture what they're doing. It's opening up opportunities to several different industries that haven't had a lot of growth in Michigan. And some of the larger companies are looking to bring to reshore projects here through a variety of reasons, supply chain, global security measures, things like that. But what we're doing is working with this global ecosystem to make things better here in Michigan. You can go to the next slide. And I mentioned this earlier in the overview. It's just the Integrate conference that's coming up in May of next year, May 10th in 2022. There's a link there to register. And like I said, essential members get a free ticket to this. And there'll be lots of information coming in the coming months and weeks on the content of that conference. And we look forward to seeing you all there. Next slide. So I think Dan's going to take over here on the accelerator. Or I can. I'll wait until he starts speaking over me because he was having some connectivity issues.
Yeah,
so
apologize for that. John, thanks very much.
There you are.
So yeah, the Industry 4.0 accelerator that John referenced is really a partnership between Automation Alley, Centropolis Accelerator at Lawrence Tech University, and Lean Rocket Lab in Jackson. We're three organizations that are very much focused on innovation in I4O and helping bring that innovation to market. It was an idea we had that was really to take a look at understanding that why we have quite a bit of innovation here in our home state of Michigan, and robotics and automation and vision systems and additive manufacturing technologies. We can't kid ourselves that we're the only place that's creating that innovation. And if our Michigan manufacturers are going to be successful, small, medium, and large, they need to be adopting these technologies state of the art. So we actually created a global accelerator that was inviting the best in class Industry 4.0 technology companies in those categories to Michigan to partner with Michigan manufacturers to consider piloting their technologies, doing live demonstrations, and then if they really help support throughput and quality and operational efficiencies and reducing CapEx, OpEx, then it's going to make our Michigan manufacturers stronger. And at the same time, it's going to attract these companies to Michigan, right? Because they're starting to get customer base, many of which are coming maybe from outside the state or outside the country. And as they develop customer relationships here in Michigan, obviously they naturally are going to set up offices, right? So it's really an economic development mission, is to help make our Michigan manufacturers better. If we improve their operational efficiencies, they're going to have better margins. If they have better margins, they're going to be more competitive when they bid on projects, and more important, relevant and competitive globally, and stay in business. We also very smartly worked with system integrators and automation distributors to be a part of our program as well. So as you know, many times selling into manufacturing, you need tier one suppliers that are certified and system integrators that manufacturers already rely on. So connecting these I4O tech companies, especially when they're out of state, to someone that already has boots on the ground in Michigan, has really worked. This is a look at all the corporate partners we have now. We have 24 manufacturers, big and small, as well as, like I mentioned, system integrators and automation distributors that work with us. We work with our I4O tech scouts, their operational efficiency teams, and we introduce some of the most promising I4O tech companies that we see, whether they come from Europe, Asia, South America, Silicon Valley, or right here in our home state. We introduce these great technology companies to the companies you see here, so they can consider adopting those technologies and demonstrating them to understand the value. So for those that are joining us today, if you're really interested to be a part of this group of companies that evaluates I4O tech companies and really looks to see if they can make improvements in your operations, we're glad to do that. There's no cost to be involved with this other than just being an Automation Alley member. So the Industry 4.0 Accelerator also has a seed fund that allows us to invest in I4O tech companies. And that's another attraction tool to, as we search globally for some of the best companies. To date, we've received over 400 applications from 34 different countries. And we've been a part of supporting 18 different pilots with Michigan manufacturers just in the short period of time, 18 months of launching the accelerator. We have 30 plus I4O tech companies that were really providing meaningful support, and 8 of which we've been able to attract from outside of Michigan into Michigan with Michigan operations, and have made seed investments in 3 companies to date. We also have thanks to the Michigan Economic Development Corporation, we also have a new pilot demo grant program. It's $5,000 offering per project. And this is just a great way to incent manufacturers to try to adopt and demonstrate technologies in their manufacturing facilities. So this grant, completely non-dilutive, would allow you that kind of offset that cost that it requires to demonstrate technologies and then evaluate them to consider going enterprise-wide. So in this presentation, which we'll provide you afterwards, is links on how to apply and learn more about that program. It does, if you do apply it obviously there's a application process that asks more about the I4O technology you'd like to adopt, who you're working with, what are the measures of success, estimated cost, timeline, and then how you're going to evaluate success in the project. So So now I'd like to talk a little bit about additive manufacturing with, you know, we spent a lot of time working with Automation Alley and interviewing companies all across the state, including our corporate partners, evaluating a lot of the applications that were coming in from across the globe to try to really understand where is the next wave of innovation, right, in additive manufacturing and 3D printing. And we're seeing it in many different ways. Obviously, if you go to the Rapid Prototyping Show, you'll see a lot of this as well. But we're looking at next generation 3D printing and very complex materials being introduced now, like silicones and tungsten and that type of thing. We're also seeing a lot of innovation in the software, right? So software that eases the design of additive manufacturing processes, makes it easier for you to evaluate just looking at the part and the materials, to build them up and layer and support structures. And then also software that's really good at kind of selecting, taking a look at your part and the type of materials you need to make it out of, helping you analyze what is the right 3D printing and materials for the job. There's also some unique software to help engineers determine what parts of a complete product or subassembly are suitable for 3D printing based on volume, timeline, cost, and even strength of materials. And then we're seeing software and tooling that also speeds up printing and curing times, right, to allow us to have better throughput in 3D printing. And then automation processes, as you see here in the lower left, higher volume kind of 3D printers that are using conveyor belts. So you have kind of a continuous printing operation. And then obviously robotics that help automate loading and unloading of 3D printers or other innovations that we're seeing. So, if you're really interested to learn more, obviously, reach out to John and I, and we'll share some details of actually tech companies we're working with. And here is just a quick, reference to some of the companies that I was referring to that have these innovations, including some of the software innovations. And then companies that are developing next generation materials like Qualified 3D, Pierre's company. Companies are developing next generation cladding systems and ability to print like in microstructures, conductive ink on polymers and glasses and that type of thing. Another example of a unique additive manufacturing technology for specific applications. The ability to apply dry fiber, carbon glass, conductive wire on textiles. You can imagine how that would support, cooling and heating and seating for automotive, for instance. We're seeing technologies that will do, both additive and subtractive processes in the same machine, like 3D Dash. And then companies that have continuous printing processes. We'll even see additive manufacturing uniqueness in different vertical market niches like Enticells. This is one of our clients. They have a cold plasma technology that basically prints on electrodes for the battery, the cathode and anode, which drastically reduces the complexity of making lithium-ion batteries as made today, reduces the footprint of the plant, the energy cost, and allows for manufacturing of thicker cathodes. So interested to learn more about any of these companies, they'll be in the deck, and you can reach out to us and we'll connect you to the companies. So this is how, if you are an I4O tech company yourself and you're on the line today, there's links on how to learn more about the program and how to apply, as well as contact for John and I and Brandon with Lean Rocket Lab. That's also a partner on this program. But now I'd like to introduce our additive manufacturing experts. Both David Bolognino with Integrated Additive Solutions and Pierre Marat with Qualified 3D are experts and residents to the Industry 4.0 Accelerator. When we see innovative I4O technologies, we often use Dave and Pierre to be our kind of experts in vetting the technology to make sure there's something unique about what they offer. And then they also help us introduce those great innovations into Michigan manufacturers. They're here to talk more about practical implementations of additive manufacturing, unique post-processing opportunities in the case of Dave. And Pierre is also going to share more about really how to generate sales with additive manufacturing. So very grateful, David, Pierre, for you guys to be involved with this event today and to share your expertise. And with that said, I am going to stop sharing my screen and ask David Bolognino to share his screen and go into his presentation. All right, you can see it. See your screen. Just gotta.
All right, thanks,
There
guys.
you go.
Appreciate the introduction and the opportunity. So I wanted to talk a little bit about what happens after 3D printing. You know, certainly a lot of companies innovating in the 3D printing space, and you know, machines have been around now for since the 80s, and a lot of technology improvements, but really not much happening in what happens after the printing. And I will suggest that it's something that needs to be addressed to scale in a manufacturing environment. First, a little bit about me. I retired from a career at General Motors a few years ago with the intention of semi-retiring, and ran into Dan, who compelled me to come and help him out at the accelerator. I was both a graduate of Lawrence Tech and on the faculty for a while, so it made pretty good sense. My consultancy is really centered around helping companies integrate additive into their workflows, as the name implies, but I also do some product development type activities through the accelerator and through some other clients. So, you know, everyone at this point on this call, I'm assuming, understands pretty well Industry 4.0 and what, you know, the attributes about Industry 4.0. Just wanted to point out at this particular point that these are all digital technologies, if you will. And so additive manufacturing is really only one of those technologies, and been used a long time for prototypes, increasingly for tooling and some low volume production. But basically, really the intersection of high value, high complexity, and low volume, and that exists in all the industries, auto, aerospace, et cetera. But really the holy grail is production. Everyone's increasingly looking in how to get to production. Of course, you have to understand what is production. Production can mean a handful of parts for aerospace, or they can mean thousands and thousands of parts for automotive. So you have to understand what production means to you. But irrespective of that, post-processing is an increasingly big part of the cost of 3D printing and manufacturing parts with additive manufacturing. This is a survey from a few years ago, the Wohlers report. You know, so you can see about 25% of the cost is attributed to what happens after the print. So the print is just the first part in the whole value chain. The post-processing investment has increased proportionally, but still the ability to post-process or post-print at scale is a significant limiting factor. So, you know, how do you define post-printing or post-processing, right? So we define that to be really one of five things, or a combination of those attributes. The first would be material removal. So that can be resins, that can be powders. It's really the stuff that's left on the print after you're done. And then of course there's support removal, which if you've had experience in 3D printing, you know that there's not a process out there that is without supports. And so those supports need to be removed. And some of them are easy insofar as they can be dissolved, but some of them are difficult in the case of metals that have to be physically removed. There's secondary processes, which includes machining critical areas, installing inserts, and et cetera. And then there's finish improvements, which is finishing the parts for a customer facing part, and painting and plating. So the level of post-processing varies, right? If you think about what the end use of the part is, if you're making a tooling fixture or a jig, you know, you could understand there's very limited post-printing or post-processing required. In the case of, say, a marketing model that needs to look like the finished product, there would be a significant amount of finishing and painting and plating. Similarly, if you were doing in a manufacturing environment, particularly with customer facing parts, you need those parts to be finished. But, you know, the problem with the post-processing as it exists today is there's a lot of variability in the process. You know, oftentimes it's the tribal knowledge of the people who are doing the work, very time consuming, inconsistent results from those manual processes. A lot of breakage. Some of the parts are still fragile, particularly in the green state. And then certainly some health and safety and environmental concerns around all of those chemicals and processes. So this is a pretty obvious example of you know, post processing. You see, this is an object machine. You see what comes out of the printer is something that's entombed in support material, and then of course what the market needs is on the right hand side. This is some sort of medical model where the supports have been liberated. Ordinarily that would be all done by hand without any process control whatsoever. So, you know, what are the inhibitors to maximizing post-printing or post-processing, right? This is data again from a survey. The first inhibitor is really the length of time to finish parts. If you think about printing a part, some of the prints, as you know, can be exceedingly long in duration, but that's okay because it's not being done with a human adding value. When you talk about now a human adding value, there's some costs there associated with the employment of that individual and lost opportunity of what they could be doing in other, you know, other parts of the value stream. A consistency in finished parts. Of course, if you've got human intervention here, you get an operator who's had a bad day or maybe is ill or whatever, and he's off his performance, and then you have parts that are no longer conforming and they're waste. The next one is the skilled labor. This is an interesting one. You know, most of the printing operations are using skilled labor to do the work, and that's basically because they're sort of offshoots, if you will, of the prototype shops or the prototype operation. So a lot of times you have super skilled labor, you know, cleaning parts, which really isn't the best use of their time. So, and then the next item is the limitations on throughput. If you think about, okay, I'm going to go build a 3D printing factory, a print farm, if you will. Now you have all these prints coming off the machines, and really the limiting factor is how to get those cleaned up and shipped to the customer. And then of course, damaged parts, which we mentioned earlier. So what does post-processing really cost, right? This was again some survey data, and the interesting thing I find about this is, you know, 20% of the respondents didn't even know what they were spending on post-processing, right? It's just the normal cost of business. They never really sat down to calculate it. That's certainly no way to run a business. The other thing that was interesting to me in this chart is the variation of what people are spending. And I think you can attribute that to what is the end use of the part. As I mentioned in the introduction, if it's a tooling aid or something, may not need much post-processing, maybe just material and support removal. If it's a customer facing part, certainly going to need some more significant cleanup and paint. But regardless, pretty limiting factor as it relates to, I think, what the audience is interested in. That's using additive for true manufacturing. So just a couple items on where those costs are. First of all, the health, safety, and environmental impact of post-processing, really not insignificant if you start thinking about some of the chemicals that are used in specifically resin removal. So vat photopolymerization, carbon, 3D systems, etc. Most of the service bureaus out there are using TPM or IPA. These are very volatile, very dangerous chemicals that need to be treated after they've exceeded their useful life. So not insignificant costs there. The cost of reprints due to lack of post-print planning. So, post-print planning is pretty important. The obvious is eliminating areas of trapped resin, et cetera, but also having enough knowledge to go add sacrificial bosses for work holding and processing in the subsequent steps. The cost of floor space, storage, and material handling, right? So this is about all of the resin tanks and depowdering stations that are taking up space that could be doing something else to add value to the business. There's the resources to train and maintain multiple processes and platforms. So a big deal in a service bureau where you're running various technologies, all of those have to have specific training. And then of course, the lost opportunity cost for using manual labor to do these operations. So, one of the challenges to enabling additive at scale is in my mind, this whole post-printing activity. If you think about Industry 4.0, you've got a digital file, turns into a digital print, art to part, and then it moves off into the finishing room, if you will, to be handled manually. Obviously, there's better ways to do that, we think, and it certainly is an inhibitor to scalability, sustainability, traceability. You think about losing your traceability in something that's very critical, like a medical device or an aircraft part, and then all that relates to quality assurance issues. So to maximize the impact for Industry 4.0, I think there needs to be some attention given to how to create a total end-to-end automated process that includes part design, printing, and post-processing. So I have one of the teams I work with is in Buffalo, New York, Post-Process Technologies. They're innovators in this space and have developed several types of machines to do resin removal, support removal, powder removal. And I think they're offering an interesting combination of machinery, chemistry, and software to help scale additive manufacturing. So if you're interested, I would encourage you to give them a look, or feel free to contact me directly if you'd like an introduction.
All right, David, are you done?
I am.
Yes, thank you very much. Yeah, I'm take a couple questions here. One that I wanted to put out there, that when you showed the slides on the cost structure, it was pretty obvious that post-processing has rather significant. I'm wondering if you know how much of that is labor, because you're right, so much of it, is labor, in some cases skilled labor, right?
Yeah, very skilled labor, and it's very skilled labor in a time where it's very difficult to get skilled labor.
Yeah.
So the depowdering and the support removal, a very manual process. I would suggest there are times when that is best done by a skilled person, be it a metal model maker, wood model maker, etc. And there are some times where maybe it's not so critical, and that's best done by what you'd call in the industry an upgrader. So a person that has lesser degree of training and skills, but still some costs there. And more importantly, in today's environment, it's a person that, as we know, it's very difficult to get employees engaged, particularly in manufacturing businesses. So if you look at this post-printing activities and some of the machines that do this. I mean, if you can eliminate, let's say 70% of your handwork by automated processes and the digital thread, that's a significant. You may not get everything. You may still have to do something and clean up and painting. It can be a significant cost reduction opportunity.
Yeah, and I've seen it myself. I mean, we have 8 3D printers, and our lab manager is a tooling engineer, right? So, and I've been in 3D printing operations with OEMs and tier ones where these are high-end engineers that are at least making $100 an hour, and sometimes that gets overlooked. Even when you price out a service bureau, you're like, why is it so expensive, right? You have the materials are cheap, parts small. It shouldn't really require that much, but I think everybody overlooks how much labor cost is built into post-processing. Can you talk a little bit about?
That's another good point, by the way, is that many of these labs originate in the engineering facilities, and so the engineering facility got their first 3D printer, and it just became custom that an engineer, a degree trained engineer, was the guy or gal figuring out how to integrate this stuff. And so years go by and they're the person cleaning up the parts, and that's not what you want either. So I think there's an opportunity for some training in this area, but type of machinery can reduce manual load significantly.
So last question here, and an important one, and you started talking about it as you were ending your presentation, this post-process company. You're seeing a lot of innovation in this space, and I know as a consultant, a lot of people are hiring you to understand what's the state of the art. Can you talk a little bit more about, to some degree, what post-process company here, as well as others, are offering to reduce that labor time or post-processing time and effort?
Yeah, so I didn't purposely put in a lot of information on the company because I didn't want it to seem like too much of a commercial. But this company offers solutions for various modalities. Certainly, the resin removal in the photopolymers, excellent chemistry and excellent machinery and software. Some depowdering machines for the SLS, selective laser sintering, that help automate the powder removal, which is not insignificant and pretty messy. But then they also offer some solutions that, let's call them tumblers or polishers, that are really adaptations of stuff that has been around in the industry, but without this digital thread. So this digital thread is important because if you start to manufacture, additive manufacture parts, you can envision, for more or less a better terms, a recipe, right? So that this part has this recipe, and the machine is able to monitor some of the attributes, temperature, amplitude of cleaning cycles, and then also the chemistry, to make sure that the chemistry is still valid. So that's where this digital thread comes in. So if you are making a part that's specific, that part gets a process report just like any other part. So you'd have the process report from the build, and the process report from the post print, and then all through inspection.
Thanks, David. I appreciate you making time today, sharing your expertise. If anyone's joining us today, or even picks up this webinar post event, as it's being recorded and broadcasted by MGA to their membership, definitely reach out if you would like to connect with David and consult with him on his expertise. Thanks, David.
Thanks.
Give me control of the screen. Yeah, give me control of the screen here, and I will switch over to introduce Pierre. So our next expert, Pierre Viadmarat, qualified 3D, is another expert that we turn to every day when we see additive manufacturing, 3D printing, very intimately involved also with the Project Diamond Automation Alley project. And he's here to talk about how you actually generate sales with additive manufacturing. So I'm going to stop sharing my screen, and Pierre, you can grab the dials and introduce yourself.
Thank you, Dan. Just a quick check. Can you hear me fine?
Yep, and I can see your screen too. You're good.
All right. Well, thank you, Dan. And so today I'm going to tackle a topic which comes very often in discussions with small and medium manufacturers who have started printing things and would like now, to see what they can do beyond prototyping and internal tooling. So there is, especially, with the membership of Project Diamond, we have a lot of these discussions. We see great things happening on the internal operations through 3D printing, whether it's for preparation of prototypes or in our case for internal tools, jigs, fixtures, grippers, like you see an example here of a 3D printed takeout robot. So there are great things that happen in-house. But the question is often, what do we do in our own activity to not only reduce costs, reduce lead time, simplify operations through 3D printing, but how do we move into the outside world? And you see examples around us everywhere, like every single example on this picture, and I could have put a lot more pictures, whether you talk about chocolate making, rocket manufacturing, house construction, or dentistry and orthodontics. These are applications where the market is changing rapidly because of the use of 3D printing technologies, not only to reduce cost, but also to find new markets and new applications. So we're going to talk today, and it would be very down-to-earth approach, so not much scientific content, but really, down-to-earth concepts and ideas. How do you build a plan to create revenue opportunities? And I will take 4 components of a plan, and we're going to talk about what to do, and a few examples. It's not an exhaustive list of what you should do to generate revenue, but just a few ideas applicable to small and medium manufacturers. So so we go concept and ideas, and then modeling. Then what do you do with the print job? How do you store it and make it a product in itself? And then how do you sell to the outside world through a catalog, for instance, of fixed products and configurable products? So let's start with the concept and idea, which is probably the most difficult thing to share here. But and I take an easy example. I used it once, I think, in the Diamond meeting. If we do a vacuum cleaner accessory, so the first step, you need to find the idea. Or we're going to do a tool to get into the crevices, and we're going to do it thin. And so you can just sketch that, get the idea. I think that's the most important part of your project. Find the concept that applies to your market. So here, you see the concept. And it's something that you can already sell, or at least you can monetize it. Then you move into modeling it. So there's also a cost of doing this, an expertise for doing this, but you can also, start at that point. Once you have the concept and the 3D modeling, you can actually use that in a different manner. You can actually sell, for instance, these models for someone else who wants to make them, or you can transmit that to a company that will make these products for you. I keep going downstream just to show the scope of how operations work. Once you have a single or a few models, you can create a print job. And so that's also something that can be stored, that can be used. The print job or the BOM can be for multiple products or a single product. I think it's an important step to consider when you are going to distribute a product in several locations. Let's say you want to create an inventory of this product in the US and in Japan and in Europe. So what you will do is to make sure that these are exactly the same products everywhere. You're not going to send someone a 3D model. You're going to send someone all the instructions, including the printer files and the sliced models or the full builds with instructions on post-processing. And that's why, David's presentation is absolutely key. Post-processing is a critical aspect of your parts. And if possible, it should be automated for end-use parts. So you're going to store that, and there's some cost of doing this, but also great value. And finally, you're going to sell these products not as a build but as a catalog reference. So it could be just the typical industrial distributor type catalog where they can pick a reference, and then it will pull from the right BOM that you have created to print your product. Or next step, you could also create a configurable product, which is made on demand by the user himself. So he can go beyond picking a simple reference in a catalog. He can define exactly what he wants. And without anyone touching the models or any file, it will generate a print model with all the instructions automatically. So 4 examples of what is required from a technical point of view to create revenue. So let me now go through examples and just practical recommendations on how you can make this happen. So I mentioned concept and ideas is probably the most difficult thing. I will take an example from a company that is a real inspiration, I think, to many people. It's a member company of Project Diamond, Zero Tolerance, with its owner, Steve Michon. And it's really interesting to see that they have invented a concept. What you see here is a takeout plate to remove, or to insert metal parts that are going to be overmolded with plastic in an injection molding machine. So they developed this innovative concept and idea and design and started using it for themselves. But what's really unique is their idea. And even though they started using that just internally, there's no reason now that they cannot bring this idea as a product that they can sell to other companies. That's actually what they are today. And this is taken from one of their advertising campaigns. This invention increases the productivity of operators and the productivity of injection molding machines that have no robot by like a huge percentage. So they have invented a concept. Now they can take it to the outside world. So if you have ideas that you have implemented in-house, don't think that it's something that you can keep only in-house. It's something that can be sold probably. So review that. I think you have experts around you. For instance, at Centopolis, who can help you work on making an idea or product and prototyping it, manufacturing it, and launching it on the market. So if you have an idea, pull from the resources around you to make it a sellable product. Now, let me move. We said we have an idea. Let's make it a concept. So let's suppose that you don't have an idea and you have great 3D printing capabilities. And so you want to sell these capabilities to the outside world. So what you will need is to receive models from someone and then make them a physical product. So you will have to receive the files, prepare them, and print them. It's a very manual process. Quoting is complicated. You need to slice or get some type of understanding of the requirements on the part before you quote. Can be very difficult to do. So you have software that's widely available. I put here a few logos. There's more companies than these 6, but I think these are 6 references on the market. They probably have most of the market share in the US for this type of software. What the software does, it allows you to automate the analysis and quoting process, and then automate the sales process when you get a model and you need to make it a print. So you see here the example. So you configure the product. You need to enter the type of machines that you have, the type of materials that you have, the type of geometries that you can manufacture on these printers. You enter price formulas, and automatically it will take a CAD model uploaded by the customer and make it a quote. So if your printer is not fully utilized, it's a good way to utilize this printer more and absorb your fixed costs. You can use it internally. You can also use it wherever you want, wherever you want to ship. So this is expensive software. Typically, annual subscription between $1,500 and $20,000, and of course more depending on the level of specialization. It integrates all your manufacturing machines, so it's really for people who have an industrial printer already and some serious plans for offering services. It has plenty of capabilities, but for most people, it is something that is quite expensive. So if you don't have that budget, let's say if you don't have $20,000 to spend on that software, what can you do? And that's a question that I get all the time. So there's a few options. Some are more ideal than others. The first type of options is that without paying any subscription costs, you can sell your products on for-profit marketplaces. I would give a few names like Exometry Hubs, Jiga, 3D Experience, that's from Dassault Systems. So they have platforms where you can define your machines, define some formulas, and get orders. Depending on the type of machines, materials that you offer, they may or may not accept you. So it's a simplified system. Sometimes, it's both a blessing and a curse, because you go there, you sell something, but your brand gets lost. Nobody knows who you are. You're just an anonymous supplier to these guys, and they take a significant amount of margin. But it can be a good way to sell some of your capacity. The other option, which is in beta phase, is a platform like Project Diamond that John presented earlier. It's a full functional version. In this case today, we have 3 of mine, fully functional. You can get access to it at a very low subscription cost. And it's a non-profit marketplace that preserves your brand. So there's this small membership. There's a small percentage, of the commission taken in the future to pay for the cost of the platform. But it gives you access to extremely powerful tools at a very, very low entry cost. So if you are not familiar with Project Diamond, and if you have a 3D printer, especially an industrial 3D printer, and you want to move into automated quoting, please check Project Diamond. It's a unique opportunity in the US. You see here, the type of things that you can do. So there's multiple functions, but one of them is letting a customer upload and get pricing for the different processes that are able to print this part. So once you have a model and you know where you're going to print it and how you're going to manufacture it, including printing, downstream operations, one way also to generate revenue is in offering the digital part inventory. And that's something that can be done by a software such as 3Omine, but other companies offer the same type of software as well. It allows you to analyze a large number of components automatically and establish a list of parts that are most likely to be good candidates for additive manufacturing. And it allows you to create catalogs of parts that can be ordered by a customer and print it only on demand. So if you take the example of the vacuum cleaner earlier, you would propose, like 100 references, but none of them are actually in inventory. And as orders come in, then it sends the part automatically to the printer or includes it in a build if you print several parts at a time. So if you don't have the industrial equipment available or the software available to create your own inventory, but you have knowledge on which parts would make sense, you can still launch that without investing too much. The value is in the design. So if you create a BOM, you can actually manufacture these products not in-house, but through the network. And that's a very powerful option. Again, it's something that Project Diamond allows you to do. You can create a part using machines that belong to other companies. And as long as they agree in giving you access to their machines at a certain price, you can route parts through multiple locations. And around Detroit, have a team of companies make your product. And it's actually a principle that is used by most service bureaus and most manufacturers. Everybody specializes in a few processes, but then buys specific materials or processes from other companies, and they help each other. There's even services that allow you to white label a marketplace. It's a brand new thing. It's a service called Auto by Shapeways. So they let you run their production equipment under your name. Of course, they take a nice margin in the process, but it can be interesting if you have ideas, but no manufacturing equipment. The last thing is, if you have also no budget for a full-blown system, you can use simple ways to make buying convenient for your customers, like have an online store or sell your products on the B2C marketplace, with caution though, because there's a lot of issues with those platforms, such as copying your IP and things like that. But you can, as long as you make the buying process convenient, you cover the biggest need, which is make it easy for customers to order your parts. Last step is, if you have already designs, you can utilize the power of 3D printing to make custom products and configurable products. So I'm putting here 3 logos. These are the leading companies. We work with some of them already, and they do custom design workflows. I give you an example here: the gripper, or the robot tool that you saw at the beginning of this presentation, something that was developed by Twinkle, and it allows you to automate the construction of this gripper by just uploading a part and telling the computer or the browser, it's just a cloud service, where you want the suction cups, which interface you need, and the weight of the part and things like that, and it will completely automate the construction. So it's something that is very convenient for end users. They don't need an engineer and a CAD system to design their gripper. They can just do it on your site. So a custom workflow such as the one from Twinkle is actually a pretty long process. You need the concept, the CAD development, the interface needs to be developed and then integrated with your systems. So these are relatively expensive systems. I would say, typically between $20,000 and $40,000 plus an annual subscription. So it's nice if it can replace an engineer and increase sales. But what if you don't have the budget for this? My recommendation right now for people who don't have a huge budget is to work using a combination of Rhino 3D, which is a popular CAD, which has a plugin called Grasshopper, which creates very nice parametric design options. And it normally runs only on Rhino, but there's another company called Shapediver that allows you to pull or upload the Shapediver definitions and run them on a web page in the cloud. So for between $50 and $500 per month, based on what you want to have in terms of integration through a frame or through an API, you can get a quite powerful configurator that attracts customers and allows you to sell your product. It's not complex. The example I give here was run by an intern at Automation Alley for a chocolate manufacturer who was going through a CAD program to customize the text that they printed on each chocolate. And it was very time consuming. And here online, you can do that. And the intern did that with zero training. I mean, she was already, an engineer, so she could understand these concepts, but it's done very inexpensively, and you can fully automate the process online for somebody who wants to order a chocolate. Other companies do the integration through APIs. So this is an Italian jewelry manufacturer where the end user can go and select the type of engraving, the type of design that they want, and immediately visualize it with a pretty good rendering online. It's in 3D, and they can order it. Last example, it's not 3D printing, it's CNC machining, but it's a lighting manufacturer allowing you to do custom designs, and you can order online. It's very, very convenient. So as a conclusion, you can easily, even if you have very limited budgets, create revenue opportunities, even if you don't have the machines, even if you don't have the IT infrastructure. Please realize that you have around Detroit great local resources, especially within Project Diamond and at Centerpolis. You can find help, and all you need is usually the idea to start with, and you'll get answers and help very quickly. And if you want help, I'm available. You have my email address. Don't hesitate to reach out.
Pierre, thank you so much. I have a couple questions for you. And then I have one for both you and David, and we'll conclude. I know we're a bit beyond the hour, but Mark, I know this is all being recorded and will be offered to MGA members afterwards. So if you don't mind. So first is, I grew up in a machine shop. I grew up as a machinist, and it's funny, I look back today and some of the parts we made for companies, and even tooling we made for companies, I could see where 3D printing would have offered us a competitive advantage, right, in our sales, had we thought about how to do that instead of like metal removal, for instance, primarily metal removal shop. And even for our own tooling and work holding and jigs and fixtures, right? We could have used 3D printing as a way to reduce our operational costs. So I really thought that was really important message that you're communicating, especially to small to medium-sized manufacturers that probably don't consider using those tools, right? For not only sales, but operational efficiency, cost reductions.
Yes. And there are some statistics among Project Diamond members. It's interesting to see, very often you see someone starts printing a very, very simple product, like a label, like almost a 2D product, a simple label. And then they get to the next idea and say, well, we're buying this. We could actually print it. And they start switching another product, and then another one, and then another one. And when they start calculating how much they save, even small manufacturers easily save, between $1,000 and $2,000 per month, direct cost saving. So it doesn't sound like much, but why not do it? It's super easy, and they can pay for the equipment in just a few months and get ready for the next generations of machines and ideas.
As long as they're also calculating the post-processing costs, as David brought on. One other question about Project Diamond, and feel free, John, to jump in. Can you talk about the value that provides? I mean, essentially what Automation Alley was able to do is to help get, free 3D printers into a wide variety of Oakland County, Macomb County, small to medium-sized manufacturers. And what I see as great value is, as good as 3D printing is, there's always a limitation based on time it takes, right? Compared to traditional metal cutting, metal forming, and, injection molding, where you can actually do high automated high volume operations. But I think what's interesting is when you network those printers, you could offer that solution, right?
John,
I
you
don't
want
know
to
if
take this?
that was, no, go
Yeah,
ahead,
John,
Pierre.
maybe you can talk to that,
Yeah.
John.
Yeah, sure. What we're finding with that is that some of the companies that are more adept are helping some of the companies that are this is relatively new for. The program itself has been designing challenges to help the companies access, their inner creativity and how to accomplish better business throughput with these systems. But I think I saw a question that kind of talks to, maybe David or Pierre can answer, what is the investment? How are these systems becoming more affordable for the companies that don't get a grant for these? And the companies, I think I know this, but do all the manufacturing companies have training systems built into the sale to manufacturers on their platforms? Is that a true statement?
Yeah, David, maybe you can answer that.
Yeah, most of the training is available for each individual machine. Some are better than others. We know the Markforged equipment through Project Diamond has a Markforged University all online. Stratasys probably has the best training. I mean, their machines are super high end, but there's actual, face-to-face training at some of their resellers like CATI. And then certain of the lower end machines are all ad hoc, but there are very few full sort of community college based additive training. And I think there's a need for that, very honestly.
Okay, thanks.
Because
Yeah,
you take
I
an
could speak to
operator.
that, like you were saying, a lot of the big 3D printing companies, like you mentioned, Markforged and Stratasys, have local companies here in Michigan, right? That are their not only resellers, but they do a lot of the training, like CATI, right?
Correct.
Yeah. Okay. One last question, because I know we're running out of time, and I want to be mindful of that. And it's kind of more of a posing a question in the future for Pierre and David. But where do you guys see the innovation? We've seen so much innovation and 3D printing and additive manufacturing. I used to be a part of Society of Manufacturing Engineers and played a part in helping run the rapid prototyping show when it was just getting started, like 20 years ago or something. So the innovation I've seen over the years, and certainly David and Pierre and John's been amazing. But I'm curious, like, what does the next 5 or 10 years bring us in the way of innovation? What problems do you see being solved, or innovation that's right now in the pipeline that you think is going to come to market? Let's start with David.
Well, I'll offer two. I know you're only looking for one. I think the first is sort of in situ process controls. A lot of these machines, as they were being built, they were being invented and built by tech companies. Very few have paid enough attention to process control. What happens when the process goes out of a control in a build, and how do you know it? That can be that can manifest itself in a crash build, which is good because you see the build crashed and you did something about it. But think about, you're making an aircraft part, maybe it's metal, maybe it's polymer, and there's an issue with the machine where you have unsolidified layers, porosity, etc. You really don't know that. And so there's a lot of, people aren't talking about it, but there's a lot of 100% inspection going on with some of those things. So these companies that have embraced how to do in situ process control and alert the operator, I think is really compelling. The second, of course, is the post-printing part. It's the sort of the dirty little secret of the industry. Everyone thinks you print a part and boom, you're done. Oftentimes it's just the beginning. So how do you reduce the labor load on that and also connect it with a digital thread so that the part is as designed.
That's great. That's insightful. Thanks for sharing that. Pierre, same question to you.
Okay, we'll let Pierre go next. I'll go last.
So on the, there's so many fields of innovation there. It's hard to pick, but I would pick two. One very short one, because I like thermoplastics, so it's one of the fields of 3D printing. There are some great technologies coming up that can actually do multi-material in a very flexible way, like companies like Evolve, where they use printing presses from the paper industry. I think when this type of technology will come out, it would be a real threat to injection molding. And I love that idea of going into the mainstream applications in high volume, which is today, one of the limits of 3D printing is like there's a ceiling today. After a certain number of parts, you need to switch to something else, except if it's a very small customized product. But in more general way, where I see the innovation is in the combination of software and hardware. And some of the most promising applications are, smart printers that can compensate for the movement or the warpage on the fly and give you a perfect part. Think about relativity space and what they do in the field of 3D printed rockets. They can print, I think I forgot, like a huge, extremely long part is the biggest 3D printed part today with an accuracy of 100 micron. And that whole thing warps, but they calculate that in advance and they get a perfectly straight rocket. So as this type of technology becomes mainstream, that's going to revolutionize the applications and the speed with which parts can be made.
That's great. Thanks for sharing, Pierre. John?
And I'll follow up on something that Pierre just mentioned is the software component. While I won't offer a specific recommendation on a specific technology, what we're seeing at the accelerator for people that are developing hardware systems, most of them have a lot more configurability than they did in the past. I mean, we all had our first encounter with a Xerox machine 30 years ago that had a certain set of functions and you had to learn their functions. More and more these things, whether they're a 3D printer or something else, a vision system, they come out of the box ready for you to customize and use to your best ability. So my recommendation for all the people watching this or joining us this morning is that you need to get someone in your business that's responsible for the software integration piece of all the tools that you're going to have in your shop moving forward. And really, either it's a new hire or start training somebody that you've got already. Utilize the ecosystem here in Michigan to get that done. And we can help direct you if you need it.
I agree, John. Take advantage of the programs that Automation Alley offers, the Industry 4.0 Accelerator, and the talent we have all around us, including David and Pierre. David and Pierre, thank you so much for bringing your expertise to bear here in today's webinar. These presentations, the recording will be made available, obviously, after the event. And I'd like to kick it off or kick it over to Mark to make kind of closing remarks. Thanks, Mark, for having us.
Yeah, absolutely. And it was very informative. It's always an education whenever I come onto these webinars. So really appreciate your time this morning and sharing all your details, and we'll get this sent out to our members. So everybody have a wonderful day, and thanks again, Dan, for facilitating the conversation.
You got it. Thank you.
Thank you, Mark. Have a great day, everyone. Bye.
Bye.
Bye now.